Do you want to create realistic lava? You came to the right place. Stay tuned and watch how it's made. Okay guys, so I'm going to go through this tiny workflow. As you can see, it's really tiny, and I'm going to explain step by step what's going on. This is actually really simple. To start with, I want a sphere, right? So I increase the frequency in order to have more resolution when I do the displacement. In this case, it's a mountain. You can do whatever you want. You can use a point bulb if you want. And I move this upwards, so we have a bigger volume. I also blasted down a couple of polygons. You can select with the letter S and blast. And I also made some holes in the mesh. For fun, I'm going to make another hole here and just add a laser. Let's move to the triangle here. With shift, you add and enter. See, it works flawlessly. So with a pick node, I just displace a tiny bit our geometry, as you can see, because I don't want it to be so close to the original geometry. Then I polyextrude this just a tiny bit. I didn't do anything apart from adding a distance. And then I used a BDB from polygons. I didn't do anything but adding a voxel size of 0.05, and then I converted this back to polygons. A low res will be okay. I made a UV project with a polar. If you go to space 5, we will see this. This is actually really small, so I added a UV layout to make it bigger. If we move this up and down, we will have this kind of interesting shape. So I chose these values and I chose to rotate it like so to have the most amount of geometry displaced on the UVs. Remember, this is with space 5, space 1, space 5. Now, points work different than geometry. They need to have everything on their points because they are not actually, well, I mean, they don't have the primitives or they don't have the vertex to move the information around. So I vertex split the UVs and promote this to a point. See, they moved from vertex and they moved now to UVs. I added some points from volume with a separation of 0.015. This will come in handy when we actually simulate the lava. But as you can see, we don't have the UVs. So we just actually transfer these values around and maybe move the threshold a tiny bit closer, for example, to 1. Nothing will change, but it's always better to be, when it comes to points, to have lower thresholds. On this wrangle, what I just did is to add the simulation attributes. I added a density to 1 and a viscosity to 0.2. This will be my source. Okay, so now that we have this, we need to create a simple collider. I always try to optimize my scenes, and so I added a poly reduce to 10%, and this will be my collision. The next step is to first of all check how the UVs look. If the UVs look like this, which are good, I'm okay with this, I really don't care about this stretching, we will be able to move to a DOP network. The DOP network will start like this, empty. So what I added is the following. I first added a flip object. The flip object is this one, and I combined my points from volume resolution around here. I copied the parameter and I went back and just paste relative reference. But when you start the data, you will have a cube. So let's go to initial data and output our source. This will be a particle field, and I'm going to go to the particle tab and add particle. On physical, I'm just going to move the viscosity and density to 0. I don't want any value coming out from here because I'm inputting these values from outside the DOP network. Then I added a flip solver. Have in mind that this will copy not anything else, but it will copy what's outside inside the DOP network. Remember, we added these values inside here with a wrangle on points 1 and point 2. We want to use this value here, so we go to viscosity, enable viscosity, and enable viscosity by attribute. Don't do anything here. Let's go to density and just toggle this on. In velocity transfer, let's go to swirly kernel. This is better. And particle motion, we will just go to behavior and add these values. You might want to use them. I am not using them, but it's always good to have these two toggled on. Let's go to recede. The receding is when, I'm going to paint this. The receding is, imagine you have a couple of points, like so, that are going downwards. So you might have the same points and it will go like in this shape. It falls down and it creates like a streak of water. But if you don't have a receding, you will have these empty spaces. So the receding will just add some points here and there, so you have a smoother geometry. That's basically what it does. It doesn't do anything else. Remember to interpolate attribute to add your UVs, because we will have new points, hence the UVs will change. So interpolate these attributes and add 4 of oversampling. Let's go to volume motion, and that should be it. So we need to add a gravity node, a merge node. Remember, the static always goes on the left, always. So let's add a merge and a static object. The static object is just our collision. Collision accept, nothing else apart from the surface collision here. And let's go to our ground plane. We don't need to do anything else. This is center, but we can move the position around if we have the simulation added anywhere else. Okay, so now that we have this, we will have these points, which these are the particle fluid surface. I'm going to make a new one. You will have something like this, which looks awful. Basically what I did is to add a lower resolution than our points from volume, because we have a resampling, remember? So let's try to go here. Did it change? Yes, it did. And I think this is good, but it's not as perfectly as I would like to. See, this changes. So let's do a quick shade and see what's the problem. The problem at the moment is the following. The problem is the following. Even though we are seeing the UVs, these are not the actual UVs, and they will change over time. Why? Because we are not transferring the UVs. Now we will see the actual UVs, and they look awful for many reasons. First of all, the radius is too small. Let's increase the radius, and the samplings are really too small. Let's add more samples. Now this looks good. We will need to adjust a couple of settings, but for instance, the influence should be smaller. So now we have more bumps, which in the lava might help us with the shading, and on the filtering we should smooth it out with a Gaussian. Now we have a mesh that might help us. Remember, this will be shaded on Mantra, Arnold, anywhere. I am not going to cover this, but I will cover the texture creation in just a tiny bit of time. So the regions, we need to subtract the collisions. Look at this. This is the shape down below. It is really smooth, and it doesn't really make sense because our collision geometry is not smooth. So let's subtract collision volumes and unplug this here. See, this is already carved out. It's because it is connected to this geometry, to our collision. Now that we have this, we can just move around, and we can always see the quick shade here. And in order to pre-visualize this, let's subdivide and toggle this point bob. So how did I create this texture? Right here on the texture DOP network. When you create a DOP network, you are faced with nothing. So let's create a generator, DOP generator. I'm going to cover this really fast and you will understand it really good. So let's go to the composite view because we are dealing with composition. To start with, we are seeing a rectangular or a 16:9 resolution image. We don't want that. We want maybe, for example, like 1024 by, okay, this is too big, by 1024. Okay, so now we have a square, but it is filled with nothingness. The difference between a point bob and a cup bob is that a point bob is based on 3 dimensions. It's based on y, x, and z coordinates, right? This is only based on 2, y and x. So we will have the position depending on where we added these points, but it's going to have a broader information because look at this. I'm going to delete this. Let's say we have a polygon. A polygon is made out of 4 points. And we can say, okay, we may have information here, 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 and there. But we don't have the possibility to add maybe some information here. How do we do this? With UVs. When you add UVs, 0, 0, 0, 1, 1, 0, and 1, 1, we can interpolate these values like so. So we can add information here, which is, let's say, 0.8 by 0.8. So now we have an interpolation. We can add points anywhere. This will work great when making textures. So how do we create these UVs? This is the X and Y, so let's plug this together. We can do back to float, like so, and before a float to vector. If we add these values here and there, we can output the same results. See? Now, as with point bobs, these noises will be affected by the position. Our position will be the UVs. So let's create a noise. Okay, we're going to plug this in here, position, and let's go here. And now we have the following, a noise. Let's make this bigger or the frequency higher. Now we have a noise, but I want to distort this. So let's create an app and basically move the UVs around. This is a noised UV. Remember, this was the original, and this is when I added some noise. We can make it 3D if we want, and this will be really interesting. So this is not going to be our noise, it's going to be our displacement of noise. It is going to be our position. So let's create an initialized flow noise here and plug it in here. Now, as we can see, we can have different results. This is quite an amazing and interesting solution to creating textures. This is black and white. Maybe we can use a fit range and move this to -1 to have the best amount of resolution in our image, because some points are negative, as you can see here. And let's say I want more contrast. Let's add a power. Let's increase the contrast a ton. And this noise is really small, so let's add, I don't know, 8 by 8 by 8. This will be our hard frequency noise, and always toggle between these to see how it changes. In 3D, it's really nice. If we add some amplitude, this will return us really nice images. And if we add some roughness, we will see everything really distorted or high pixelated. So let's add 0.2. This is interesting, but I might want some more. And okay, this is nice, but it's boring, really boring. So let's add some more noises here and there. So this will be our high frequency noise, and now we're going to create more noises and merge these together, like so, and plug this in here. We are just seeing this same noise added on top of each other once and over again. So let's create this mid-res solution or a mid-frequency noise. There we go. So this, as we can see, we have some interpolation of noises here and there. Let's just move this lower, and let's move this actually up a little bit to 15 maybe. Let's say this, let's move this around. I think this is okay. We can increase the amplitude a tiny bit, and now we have some really nice noise. And the last one will be our really big noise. 1, 1, and 1. And this is okay. We can move this around and see what it does. I think this can be okay. This is okay. We can move these values around to create a texture, and this is actually nice. I want maybe more amplitude here and there. Okay, so now that we have this texture, which is nice, you can see how it looks with color. Let's add a color ramp. I don't know what I added. A ramp parameter. This will be our test, and this ramp will be our texture. It is a good practice to have always different ramps, one to test everything out and one to actually see the final result, and you'll see why now. So this will go to input 1, the switcher will be promoted, and we will be connecting these two guys together. So our test will range from 2 to blue, and we're going to plug in every value on an RGB scale, and I'm going to teach you something. So we will see these colors if the range is supported. We're not seeing red a lot, so I want to see more red. So let's go here and maybe increase the amplitude a tiny bit. We'll have more detail here, but what we want to do is maybe increase this power so we have more contrast. Now it's interesting. The red will be our black, the blue will be our high values. So now that we have this broad range, this whole spectrum visible, we can move to our shading. This will be black and white, but for example, let's an orange here. Now we have this grading, which is actually really nice. It's another color. This might be, I don't know, a saturated dark color. And look at this. This image is awesome. Let's create a null that will be called out texture, and let's add a raw file output. This will be our texture, and we can even output the following. I'm going to go to my desktop and save it as lava.jpg. So now that we have this, well, I made it the same here, it doesn't really matter, but we're going to delete this texture and I'm going to replace it here. Texture. Oops, texture. So if we go in here, I added this texture node that will go to our CD. Since we have the UVs, our texture will just follow properly, right? So I'm going to grab this lava and see how it looks on the mesh. Let's go back to scene view and see how it looks. This is with the quick shade, this is with the subdivide, this is with the point cloth, this is without our quick shade, and the texture is here. This is a flipbook without, or this is a flipbook with a different shading. This is another texture, but the idea is the same. So if you see some flickering, it's because this is a point base. This is only for pre-visualization. When you go to the shading, you will actually be using our UVs, and the interpolation, as we said before, on this image will be smooth. Hey, I hope that you enjoyed the video. If you want to know more about this stuff, you can join to my Discord channel and subscribe. If you subscribe and hit that bell, you will see every week I upload a different tutorial. So stay tuned, and until next time.